All right, welcome back, everybody. Today we are going to be talking about standard SR2, which is adding and subtracting radicals. Now, it says write each expression in simplest radical form. What we're going to be talking mainly about today is how we add and subtract these things. Yesterday we talked about how to simplify, and that's surely going to come back into play today, but our main focus is going to be on how we add and subtract. And basically, the way we add and subtract is very similar to something we've already done. Remember, if you would have had, let's just say for this example that x is equal to the square root of 13. Then I could rewrite this as 5x minus, well, I could put a 1 on the outside here. That's not going to change anything, 1x. Now, if we were dealing with this and we had 5x take away 1x, we would have said that we had 4x. And what we should hopefully remember is that x is really just equal to the square root of 13. So I can come over here and replace the x with the square root of 13. Now, the reason this was so easy to do for us is because of the fact 5 square roots of 13 and 1 square roots of 13 have what we call like radicals. Like radicals are when they have the same number inside the square root. And when that's the case, you're able to combine those two piles together using just normal rules, but you don't ever change the inside. Here's another problem though. And in this problem, what you're going to notice is that the square root of 7 and the square root of 3 are not the same. And if they're not the same, then what you cannot do is you cannot put these together. So our final answer on this problem would be 2 square roots of 7 minus 4 square roots of 3. If they don't have like radicals, you cannot put them together. Now, let's look at this one. We have 3 of them being added or subtracted together. So I have 6 square roots of 11 plus 5 square roots of 11, take away 1 square root of 11. You can put that 1 in there if you don't see a number out front. So if I have 6 plus 5, this would give me 11 square roots of 11. And then if I take away 1 square root of 11, that would give me 10 square roots of 11, which will be my final answer. So as you see, adding and subtracting radicals isn't that hard as long as you have the like radicals. Now, look at number 7. Right away, we can see that 20 and 5 are not the same. Now, one thing we should always remember is just like with fractions, anytime you give an answer, you always want to make sure it's in simplest form. And what that means is that if you can break down one of these square roots, you need to. So let's break down 20. 20 would turn into 2 and 10. 10 would turn into 2 and 5. And then I could rewrite the square root of 20 as 2 times 5. And then this is plus the square root of 5. Now, just like we've done before, remember if you have 2 of the same thing, you can pull one of those to the outside. We call this our 2 for 1 special. These 2 disappear, and you're going to be left with 2 square roots of 5 plus the square root of 5. Now, what you notice, hopefully, is that after we went through and actually simplified it down, these 2 ended up being like radicals, meaning we can add them together. So if I have 2 square roots of 5 plus 1 square root of 5, that's going to give me 3 square roots of 5. Nice job. Let's go to number, what else we got here? Do we have another one? There we go. Let's go to problem number 9 here. So here's another one. Remember, first thing you always want to do is try to break it down. So this would be 2 and 10, and this would be 2 and 5. So I can rewrite the square root of 20 as 2, 2, 5. Now, 45 can also be broken down. 45 is just 9 times 5, and 9 is 3 times 3, and these are all my ending numbers. So I can rewrite the square root of 45 as 3 times 3 times 5. Excuse me. Now, at this point, what you want to do is if you have any 2 for 1s, you want to pull them out. So I'm going to pull out this 2, and I'm going to put it in front. So this negative is going to pop in front of the 2, so this will be a negative 2. And then I still had that 5 that was left inside. And then on the other one, I'm going to pull the 3 out in front. And I'm going to still keep the square root of 5 over there. If I have negative 2 square roots of 5 plus 3 square roots of 5, that's going to give me 1 square root of 5. And we're done, just like that. So the simplifying work that we were doing yesterday is still extremely important for us today. Here's another problem. This one looks intense. We don't have any like radicals yet, but let's simplify these down. So 20 is 2 and 10 is 2 and 5. 8 is going to be 2 and 4, which is 2 and 2. Should circle all my ending ones so I don't make any mistakes. 50 is going to be 2 and 25 is 5 and 5. So when I rewrite this, I'm going to have 2 square roots of 2, 2, 5, 2, 2, 5, plus the square root of 2, 2, 2, minus 5 square roots of 2, 5, 5. Now, at this point, you want to do any 2-for-1 specials. So if you have 2 2's, you can pull one of those 2's to the outside, and then these 2 2's will get multiplied together. 2 times 2 is 4. So this whole term will turn into 4 square roots of 5. The reason we still have the square root of 5 is because we still had a 5 on the inside. When you get to the next term, do your 2-for-1 special, 2 of the same, pull one out, cross those out, and what we find is that that becomes 2 square roots of 2. Last but not least, we have a 2-for-1 special on the 5's, so we can pull that out. So I'm going to have negative 5 times 5, right? That extra 5 is now sitting right here. And then the square root of 2 is still here. So negative 5 times 5 is going to give us a negative 25, or a minus 25 square roots of 2. Now, at this point, we want to look to see if we can add any of these together. And what we'll notice is that we have like radicals here and here, but the square root of 5 over here is not a like radical. So here's what that means. We can put this and this together, but we can't combine it with the 4 square roots of 5. And that's okay. So we'll have 4 square roots of 5. If I have 2 square roots of 2, and I take away 25 square roots of 2, 2 take away 25 would be a negative 23 square roots of 2. And this would be our final answer. Once everything has been simplified, and if possible, combined because there was like radicals, then you're done. Looks like we got 2 more problems. So here's number 13. So looking at problem number 13, we have the square root of 16, which we know is 4 and 4, which should be 2 and 2 and 2 and 2. Taking all of our ending numbers, we can rewrite the square root of 16 as 2 times 2 times 2 times 2. If we break down 4, that's going to be 2 times 2. So we can rewrite this as negative 7 square roots of 2 times 2. And then plus 2 at the end. At this point, you want to do your 2-for-1 special. So if you have 2 2's, you pull 1 to the outside. If you have 2 2's, you pull 1 to the outside. All of these get multiplied together. 2 times 2 is 4. 4 times 3 is 12. And then if you look, there's actually nothing left inside of this square root. It's all been pulled out. So that means that this square root is no longer necessary, and we don't need to write it. So basically, 3 square roots of 16 became just 12. Now, as you move on to the next one, you have 2 2's, so you can pull 1 out. So you're going to have negative 7 times 2 on the outside, which is going to be a minus 14. And then again, there's nothing left in the square root, so the square root actually just goes away. And last but not least, you'll have that 2. So 12, take away 14, plus 2 will give us 0, which will be our final answer. One more. Looking at number 15, you get 75 to start. We first want to begin by breaking that down. So 75 will be 3 and 25. 25 will break into 5 and 5. So we can rewrite 2 square roots of 75 as 2 square roots of 3 times 5 times 5. We can do our 2-for-1 special right now if we wish. So we can pull out a 5. 2 times that 5 will end up being 10 square roots of 3. Now looking over here at 12, 12 will be broken into 4 and 3, and 4 could be broken into 2 and 2. So the square root of 12 will be rewritten as 2 times 2 times 3. 2 of the same, pull 1 out. So I'm going to get a 2 on the outside. The 3 was left inside, and these were being added. So if I have 10 square roots of 3 plus 2 square roots of 3, that would give me 12 square roots of 3. Thank you guys so much for watching the full video. If you have any questions, please make sure you're reaching out for help. Yeah, thanks guys. Have a good day.